name is Christina Bresinger. Maybe someone of you knows me as Christina Flitsch. There was a last name changing during the summer. Before I get into my topic of today, I want to give you some background information. I have already presented at SUMO conferences the last year within the ITS Upper Austria team, where we develop real-time traffic information for Upper Austria. And we use a mesoscopic simulation as a method to fill up data gaps when we don't have sensor data. But today, I don't want to talk about how we develop the real-time traffic information. I would like to talk about the mesoscopic settings in the simulation itself. And the model we have has over 200,000 edges. It is the complete Upper Austrian model. It is only a small part of this model. And this model consists of various network characteristics. So, for example, you have, of course, suburban areas, urban areas, and rural areas, but you can also zoom into each map and you can see that there are a lot of different road types and characteristics, like the road function or crossing time and so on. And with a very large traffic model, you all know it, recalibration can take a lot of time. So when we actually try to recalibrate this model, sometimes it recalibrates over 2 weeks, and then you need to search for certain points where you can evaluate the whole model. And for the real-time information, we use the offline model and we then recalibrate it online. So the offline model should be already quite good. And that's the point why I decided to investigate the mesoscopic settings, not on the large model of Upper Austria, but to build a model only for this investigation. And I called it here the test network. And I designed this test network with using all these different characteristics of the road. And I tried to make it very small, but to fill up it with everything that you needed. And for example, I want to show you the edge 2, which is here, because the results I will depict you later will be on this edge 2, and it has an allowed speed value of 90 kilometers per hour, and it should represent a road which is coming from a suburban area into a more area. So that about the setting where I tested the mesoscopic parameters. The question is now, how did I do it and why did I do it that way? So I chose, in the first step, I wanted the time sensitivity analysis. I did a small literature research and I decided to change one parameter or the value of one parameter at a time on this network. This means, for example, if you have the edge length, you can, I changed it from the default value into certain amount of meters. I will explain it later, one at a time. And then I created for every setting my output data. And this output data I compared to each other. So I checked, was there really a change in the output data when I changed the value, or was it not? And when there was a change in the value, I I tried to identify how the model was influenced. And therefore, I used a fundamental diagram, and I created a small code in R where I was able to import the SUMO output data, and I analyzed the maximum density, the critical density, the maximum speed, the maximum traffic flow, and also created the diagrams itself to have a visual investigation and to check if the distribution has changed. So, what parameters are possible in a mesoscopic simulation model? One parameter, which of course is not here because it is essential to use it mesoscopic, is to enable the mesoscopic model. So before you work with SUMO as a mesoscopic model, you need to enable it. Then you have different possibilities, and there are 11 different mesoscopic parameters. I will go deeper into the edge length and the gem threshold. Later on, I will shortly talk about the tau value, and you can find there more results at the paper, but I will not present it here, and I will show you why. When I investigated the mesoscopic parameters, I needed something where I was able to compare it with. So because this was just a test setting, and I didn't have any sensor data for this test setting because I only designed it by myself. So I decided to create two models. The one was within a microscopic configuration, because my goal is to create a mesoscopic simulation which runs very fast, but it should be as nice as a microscopic simulation, I would say. And the other model I used was I called it Meso-1 model, because it was the model which is, it are the configuration settings which are already used in the Upper Austrian simulation. And there we enabled the junction control and the overtaking additionally to the default values. And nothing else was changed at the moment where I started to investigate the mesoscopic parameters. So I will show you some small examples, and I want to explain to you some findings I have, and I will just do it in one. So at the left side, you can see the microscopic output, and on the right side, you can see in blue the Meso-1, which means the default values with some additional enabled mesoscopic settings, and the Meso enabled. This means I only enabled Meso, and these were these default values. And maybe you see it right away. There was a problem within the speed, the maximum speed, because as you can see, before I mentioned that the speed was 90 kilometers per hour for this edge 2. And here you can see that the speed was much higher than the 90 kilometers per hour. And this was a problem which appeared when I checked the Meso enabled model, and I found out that it was also in our real simulation model, in the ICS Upper Austria model. So thankfully to Jacob, who is always replying on the forum, I was able to solve it by setting the speed deviation to 0, and I could fix the problem, but I'm not sure if there come up some other problems with it. All right, so as you can see, when you enable the mesoscopic simulation, the deviation of the fundamental diagram has changed significantly. And in addition, as I mentioned before, I tried out a lot of different settings for all of these parameters. But what I didn't mention was that I did not only change one parameter at a time. After I've done this, I also combined those values, which I thought were quite useful. So here, I wanted to show you how I combined the meso edge length and the meso temp threshold. I tested the edge length for a lot of different values and the threshold as well. The threshold, therefore, the best result was when I set it to minus 0.33. And that means that the a segment is considered as jammed when the current speed is below 33% of the speed limit. And these 33% actually come from a requirement of the Eissfeldt project, where ITS Upper Austria is one part of it. So in my study, this was also considered. And I also investigated the edge length deeper, and there I did some tests, because SUMO could have either cut the complete segment as a complete network into segments by starting at one point of the network and cut it in segments of the same length, or it was possible that SUMO cut it when a real edge of the network has ended or started. And I found out that this is actually the case. And for me, this was important because it means that you need to be quite careful when you have a large network and you, for example, reduce the network by leaving out roads which have a low road functionality, so which are not important for traffic management. And sometimes then edges are just connected to each other and crossings are left out. So in this case, that's something you shouldn't do. All right, so I now talked about the edge length and the temp threshold, but I also investigated the tau values. And I used a SUMO version which was below 1.08. And therefore, you only were able to set one tau value for the complete simulation. And this was a little bit of a problem because the tau values should depend also on the traffic volume. And if you just set it for a complete simulation, when you have so many different characteristics, it can be very challenging. But as I found out, in the newer SUMO versions, it can be adjusted the way that you defined a road characteristic, and you can set the tau values for these roads. So I didn't do it already, but I'm planning to do it. Yeah, what I also found out about the edge length was that the shorter edge length is, the better the output data was in my view. And for the gem threshold, computing it within the speed limit turned out to be the best way for my use case. All right, so I used my findings to adjust the ITS Upper Austria model. This is already done. So what did we do? I went to my project partners with my findings, and they recalibrated the simulation within the new setting. And we found out that the model was better than before, and what should be done to check out the new tau functionality and to also add this into the model, because I think that it would have a large impact. Thank you for your attention.